Hi everybody, welcome back for day 3. So today we're going to be talking about Boolean expressions and control flow. So it's going to be really important today to follow along in the on the Tacos, the computer science website. Some of the stuff it's just a lot easier to work with if you can follow along on the website. So let's start with Boolean expressions. So a Boolean expression is some mathematical expression that always evaluates to either true or false. So it can only ever be true or false. So if you're following along on the website, you can see our first example there is 10 is less than 5. So that expression is 10 less than 5 evaluates to false, right? So because 10 is not less than 5. So you might be familiar with the less than sign, the greater than sign, the less than or equal to or greater than equal to signs, those symbols. We have a couple more that we use in programming, the equal to and not equal to signs. So if you're looking on the website here, we have the less than sign, the greater than sign, and then for the rest of these, there's multiple ways that you can write them down. So in MakeCode, the right side, so like the less than sign with the line underneath, that's the one that you'll see in MakeCode. I included the ones that are on the left side because in written programming languages, you don't have a symbol on your keyboard for the less than sign with the arrow underneath, and so typically in written programming languages, you'll use some version that you can make with the keys on your keyboard. So the less than symbol and then the equal symbol. Same thing with equality, especially in almost every programming language, written programming language, you'll check for if two things are equal, you'll see two equal signs instead of one equal sign. In MakeCode, we don't use the equal symbol to set a variable equal to something, and so we can just use one equal sign, but just be aware of that if you ever look at other programming languages, or even in MakeCode, if you look at the code in JavaScript, you'll see the double equals. Alright, so if you scroll down a little bit, those last two paragraphs above control flow. So the values on each side of a Boolean expression can be numbers, like in the expression is 125 greater than or equal to 32. So obviously that evaluates to true, right? 125 is greater than or equal to 32. But they can also be math expressions. So and especially they can include variables, which in programming they almost always will include a variable. So if we look at that next example, 7 times 5, is that equal to 7 times counter? So 7 times 5 evaluates to 35, but 7 times counter, well, we don't know that evaluates to because we don't know what the value of counter is. And counter might change, the value of counter, so if that's a variable in our program, that might change throughout our program. But whenever that we have a line that checks for equality between the left and right side, if counter is equal to 5 in this case, then it will evaluate to true, but if it's anything other than 5, it'll evaluate to false. So we'll use that a lot in programming, checking if things are equal or not equal. But they're especially useful in programming. Boolean expressions are when they include a variable. So one of the main reasons that we use, or one of the main things that we use Boolean expressions for, is to help us control the flow of our program. So control flow is the path that our program takes while it's being run. So often we want different things to happen when certain conditions are met. For example, we could write a program for the microbit that tells us what outfit or what set of clothes is appropriate for the temperature outside. So the microbit has a temperature sensor, right? We could have a microbit outside and it could tell us what the temperature is. And not only could it tell us what the temperature is, it could tell us, like, hey, the temperature is, it's hot, so wear shorts or whatever. So how we would kind of structure this using Boolean expressions is if the temperature is above 60 degrees, so our Boolean expression is temperature greater than 60, so if the temperature is above 60 degrees, then the microbit should show a picture of shorts. Else, if the microbit is at or below 60 degrees, then it should display a pair of pants because it's cold, right? So there are two paths that our program can take. It can either it can check what the temperature is, and then one of two things will happen. Either it'll show shorts or it'll show pants, And so we have these two different paths. So the control flow of our program is kind of what path is our program going to take. So if we ran it and the temperature was, say, 75 degrees, it would show shorts, and in that case it wouldn't show pants at all, right? And even though we wrote that code. So not all code is always executed, and that's one of the things that we use control flow for. So let's open up make code. I'll switch my camera here to my view as well. So let's open make code and make a new project. So we can just call this control flow. So create a new project here, control flow. And we're just going to test a couple things out here, right? Or we can actually, we're going to make that temperature program. So Boolean expressions and control flow, so we call those logical statements here. So if you open up the logic tab on the left here, you can see that if true, and if true then something, if true then something else, something. So kind of two different types here of if statements. We're going to use the one that has an else. So on start, if true, then something, else something. So right now this isn't going to do anything because you don't have any code in there. But if you follow the picture that we have on the website there, the code, we want to go grab a less than comparison. So this is one of those cases where if you're looking for a greater than, you're just going to want to grab the less than, and then you can change it to greater than. So in this case, we do want a greater than. We're just going to snap that in. So if you notice that the ends of these is a triangle, right, a pointed shape, and in here, this takes a pointed shape. So we know this snaps in there. Okay. So the temperature sensor we talked about is an input. So it's going to be on the input tab because we're getting information into the microbit, right? It's sensing what the temperature is. So we have this down here, this temperature. So we can put this, replace that right here. So now if temperature is greater than 0. So in this case, we've said that 60 degrees is our cutoff for whether or not we're going to wear shorts or pants. So let's change this to 60. Okay. So if you're kind of reading this on start, so when the microbit starts, if the temperature is greater than 60, then do whatever is in here. So right now we're not doing anything. So let's we want to say, hey, wear shorts. So one way we could do that is draw a pair of shorts. So try to copy what I have written down here already. So we can do kind of this thing right here, right? So we'll say those are shorts, and maybe it'll look more like shorts when we see what the pants look like. But okay, so if the temperature is not over 60, then it must be below 60, right? Those are kind of the only two options that we have. So that's what this else statement does. Basically, if this condition, if this Boolean expression up here is false, then this doesn't happen and the else statement happens, whatever we put in here. So if the temperature is greater than 60, then we're going to show shorts. Otherwise, we want to show pants, right? Because we're going to wear pants. So we can kind of draw a pair of pants here. Right on. Okay, and pretty simple, but this is our entire program, right? On start, if the temperature is over 60, we're going to show shorts. Otherwise, we're going to show pants, right? So if the temperature is less than 60. So, I have a little challenge for you here. One problem that we have with this program, though, before we can be done with it, is that if you look over here in the top left, it's saying 20, so we can change kind of what this virtual microbit, what the temperature is, since it can't actually sense the temperature. Only our physical microbit can do that. You might notice that this is listing it in Celsius. So, I don't know about you, but Celsius temperature doesn't mean a whole lot to me. I know that 0 is freezing and that 100 is boiling, right? But I'm not super familiar with Celsius, so I actually wanted to read this in Fahrenheit. So if you do the conversion from 60, that's way hotter than it really is ever going to get outside. And so this this program is incorrect in the sense that we don't want it to be 60 degrees Celsius, we want it to be 60 degrees Fahrenheit. So that's the challenge that I have for you. If you go back to the website and go down to the activity temperature sensor, go ahead and follow those steps And I've got a couple hints for you and some examples, but you'll have to use the variables that we talked about yesterday. You'll have to use a variable to figure out how to convert this temperature block that we have here, right, to Fahrenheit. So go ahead and pause this video. Again, I did put a solution there, but do your absolute best to try to figure it out before you look at the solution. But go ahead and pause the video and try it out. Alright, so hopefully you had a chance to try to convert this temperature that we had to Fahrenheit. Pretty cool, and most of the time when I'm using the microbits, I'm going to want my temperature in Fahrenheit, so something that you use pretty often. So the next thing that we're going to talk about is loops. So I'm going to go ahead and start a new project here and just call loops. And let's go through a couple of the different type of loops we have, or talk about what a loop is. So loops are just another method that we have to control the path our program takes. So a lot of times in programming, especially because we use computers to do problems that are just like too long or too hard for humans to solve, we want to do things over and over and over again. And instead of having to write code that just repeats itself over and over, we can put a certain amount of code inside of a loop, and then that code will just run over and over. So there's lots of different types of loops. They're in the loop tab here. So let's look at a couple of these. So let's talk about this repeat loop first. So if we drag this repeat loop into the onStart block, if you're looking back at the website, there's an example that I have listed there that shows a heart. It pauses for a little bit, it clears the screen, and then it pauses a little bit. So let's recreate that, and then we'll kind of talk about what's happening. So I'm going to throw the heart icon in here. I'm going to come back in here to pause. So on pause, literally, it just does kind of what it sounds like. It pauses the program for a little bit, which would also be an element of control flow. So, okay, then we're going to clear the screen, and then we're going to wait another 100 milliseconds. Okay. So now, if you're looking at the top left here, you can see our heart is blinking on and off. Let me restart that so you can look at it one more time. So the heart's on, and it's blinking off and on, right? So that's what our program does. So it takes, this loop is going to repeat 4 times, and it's going to do whatever blocks we've put inside of it, and it's going to go from top to bottom and then back up to top 4 times. So let's change it to, let's say 6, and we should see our heart blink about 6 times. So we got 1, 2, 3, 4, 5, 6. Right, so the it turning on kind of counts as a blink in this case because we're turning it off at the end. So our loop here, it does this code 6 times, right? So we could change it again to 2, and we would just see it come on and off, and then back on again one more time, and that's it. So the repeat loop, it just lets you pick however many times you want this code to run. So we could also replace this too with a variable, right? Maybe we don't know how many times the loop needs to run until we've done some other calculation, so we could just drag a variable over this 2 and replace it. Alright, so let's talk about a different type of loop called the while loop. So I'm going to go ahead and delete this, come back up and grab a while loop. So this shape right here should look familiar, right? So we were just talking about if statements and these triangle kind of shape, these diamond shaped blocks in here. So the while loop will keep repeating the blocks that you put inside of it until the Boolean expression, so we've been talking about Boolean expressions, right? Until the Boolean expression that you put right here becomes false. So as long as the Boolean expression is true, it'll keep running forever. But as soon as it becomes false, the loop will stop running. So let's look at an example here. So let's start a variable here. I'm going to call it counter. Okay. I'm going to set the counter to 0, and I'm following the same exact example that's on the website here too. So let's set the counter to 0, and then let's make our Boolean expression. So while counter is less than 10, then we're going to do the same thing. We're going to do that blinking heart. So let's show the heart. Let's pause. Let's clear the screen, and then let's pause again. Okay, so if you look at this code right here, so we have we've created a variable counter, we've set it equal to 0. So while counter is less than 10, run this code. So if you've noticed, this has started running up there, so it's going to run over and over and over again until this expression becomes false. Well, we never change the value of counter in this code, right? Counter just stays 0 the entire time, and so 0 is always going to be less than 10, and so this code will actually run forever. So when while loops become useful is when we start changing the value of counter inside the loop. So if we, kind of like how we did with our counter program, so if we set counter to increase every time the loop runs, so we could set counter to counter plus 1. Then each time that the loop runs, the variable counter is changing, and eventually it will stop. So this is just restarted, so you can see we're at like 4, 5, 6, 7, and then we should see it stop. And it stopped, right? Okay, so in this case it is running 10 times because at the bottom of this loop, counter goes up by 1. So we set counter to 0, it comes in here. Is counter less than 0? It is, so it runs this block, then this block, then this block, then this block, then it runs this block, which sets counter to 1. And then it comes back up to the top and it checks this condition again. So now counter is equal to 1, so is 1 less than 10? It is. So we go through the loop again, and then counter becomes 2. Is 2 less than 10? It is. So this runs until counter is equal to 10, and then it comes back up and it says, is 10 less than 10? False. And so in that case, none of this code runs, and then you're back down to the bottom. So if there was a block after this, it would run. So while loops are pretty similar to the repeat loops, but you can put a Boolean expression in there to figure out how many times you're going to run your code. All right, so the last loop that we're going to talk about for now is this forever block. So this is actually kind of a special type of loop that just runs forever. So just kind of like our while loop was running forever before, this forever loop just runs forever. So it's not in the loops. It's just so common to use this forever block that they put it in the basic tab. So any code that you put in here, so well, let's use our heart example again. So if we write that same heart example, the blinking heart here, you can just see, we'll let it run for a little bit, and you can see that it does in fact run forever. So as long as the microbit has power, that code is going to run. Another pause. Okay, so you can see it's restarting, and we should just have a heart start blinking, right? And as long as our microbit has power going to it, as long as the microbit is turned on, this code is just going to go from top to bottom and run forever. All right, so those are a few of the types of loops that we have. There are other types of loops. We're not going to talk about those right now, but there are lots of resources, and some of the tutorials might go over them and help you learn a little bit more. So if you go back to the website and go down to, so we've talked about each of the blocks. If you look at the activity, sum from 1 to x, just go through that activity. Another one that I will include a solution to, or I have a solution at the bottom, but follow it along and use the loops and try to get a little bit more comfortable with those. So we'll use those more later on during the week. And yeah, loops and control flow in general are things that we use all the time in programming, and they're super important. So go ahead and pause this video and give that activity a shot, and come back when you're done. Alright, so hopefully you were able to complete that activity, the summing from 1 to x activity. These type of problems are things that are really useful to have computers for, right? It's these math problems that would take us forever and ever and ever to do, but computers can do it, within seconds or sometimes even less. So today we went over Boolean expressions, right? So expressions that always evaluate to either true or false. And then we learned how to use if-else statements to control the flow of our program, as well as loops to control the flow of our program. So we can use loops to repeat the same code over and over. So tomorrow we're actually going to take a little detour away from programming in general, and we're going to talk about electrical circuits. So I will see you tomorrow.